the educational and health distribution at baseline that I just showed you. Now, one of the first things we did in the obesity project is the following. We wanted to draw some pictures to understand, is it or is it not the case that there are clusters of obese and non-obese individuals within the network? So this is a graphic that shows, again, nodes. This shows the largest connected subcomponent of the network. There are just 2,200 people in this network. We make the node size proportional to people's BMI. So bigger people get bigger nodes. And then if their BMI is above 30, we also color the node yellow, to sort of give you a visual clue that this person is overweight or obese, versus green, the person is not. And then we have two different kinds of colors for the ties here. The purple ties are non-genetic ties, friendship or spousal ties. And the orange ties are potentially genetic, namely familial ties. And if you squint here, you might see that there's some clustering of obese and non-obese individuals within the network. Now, I can look at these images now because I've been looking at them for a long time, and I can look at this image and see that actually there is a tendency of some clustering, but we actually need a more formal mathematical way of persuading you that there is clustering, number one. Number two, persuading you that any clustering that is there is more than would be expected by chance alone, because by dumb luck, if you seat people in a stadium, maybe you're going to have clusters of women and clusters of men, and you want to know, is that clustering exceeding what would be expected just by dumb luck? And number three, if there is clustering and it's more than would be expected by chance alone, we would like some way of telling you, well, how big are those clusters? Are they small? Are they large? How far do they reach, right? If you get an obese individual or a non-obese individual, because both cluster, does it extend far or near into the distance? Now, in order to do this, we had to exploit some techniques that had been previously used by my colleague Laszlo Barabashi, who's a physicist that's been studying networks for a while, and most recently has been studying networks of genes. And so we are going to use what's called the topological permutation test. But I think I can walk you through it and explain why that test is so valuable in the current setting. Imagine that we have a situation in which we have a network of people, and 40% of the people are obese. And that the obesity is randomly distributed through the network. So now we have this random BMI network, and in the center we have an obese individual who is orange in color, and that person is connected to 5 friends or siblings or social contacts 1 degree removed in the shell of this onion. You would expect, in expectation, by dumb luck alone, 2 out of 5 of those individuals, or 40%, to be obese. Okay? If you go out 2 degrees removed, and now there are 15 people in that shell of the onion, you would expect 6 of 15, again, 40% of the people to be obese. And if you go out 3 degrees removed, you would see, and there were 25 people in that shell, you would expect, in expectation, 10 out of 25, or 40% of the people to be obese. So at every degree removed, you have roughly, on average, the same, from every obese individual, the same prevalence of obesity as is seen in the total population. On the other hand, if there's clustering, if there's not a random distribution, you'd get what you see on the left. So in the middle, we have, again, an obese individual, but you go out 1 degree, you'd see 3 out of 5, or 60% of those persons, the obese person's friends, would be, or social contacts would be obese. 2 degrees removed, 7 out of 15, or about 50%. 3 degrees removed, 8 out of 25, or about 32% of the individuals would be obese, okay? What this means is it's like you have like these peaks and these valleys in sociotopological space. You have this kind of social network pattern that defines this kind of terrain, and you have peaks of individuals who are overweight going down into valleys of people who are normal weight. And if you pick me and if I'm underweight or overweight, and you move a certain degree removed from me, every step away you remove from me contains some information about the probability that these individuals would be obese or not. And you have to go 3 degrees removed or 4 degrees removed before there's no longer any association between the body size of the person that's my friend's 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 friend and my body size. And one can do this and then generate a variety of statistics that tell us whether the amount of clustering that's observed exceed that which would be expected by chance alone. You can create these sampling replicates that allow you to do that. So when you do that, what we find, in fact, is the following. This slide shows on the y-axis the relative increase in the probability of ego obesity. Ego is me, alter is Denise. Conditional on given alter is obese. depending on the altered social distance. Are we talking about my friend or my spouse or my sibling or my friend's friend or my friend's friend's friend, 1, 2, 3, up to 6 degrees removed of Kevin Bacon. So we get here 1 degree removed, and you can ignore the waves, the number of waves that are shown there. That's just the wave of the examination. What we find is that it alters distance 1 from an obese individual have 40% excess risk of being obese than would be expected due to chance alone. Alters distance 2 have roughly 20% excess risk of being obese than would be expected due to chance alone. Alters distance 3, regardless of time, regardless of wave, have roughly 10% excess risk of being obese than would be expected by chance alone. You have to get to 4 degrees removed before there's no longer any association between the weight status of a person that far away from you and your own weight status. So what we have now shown is that there is, number 1, more clustering than would be expected due to chance alone in the network, and that this clustering extends out to 3 degrees of separation. Your weight status is related to the weight status of people who you might not even know who are 2 or 3 degrees removed from you.
Question?
Yeah.
So in the cluster diagrams, you took the 25 as given. Is there also a feedback into a characteristic like a health challenge or behavior that limits the size of that? Smokers might have smaller social networks. Does that factor?
Okay, so the way we do this, the way the statistics work is we observe the topology and we fix it. And then we observe the prevalence of obesity, and then we take that topology and randomly distribute obesity through that network. And then we do that again and again 1,000 times. And then we get a sampling distribution of the clustering of obesity around every obese individual in the random network, and we test the hypothesis that the clustering, the observed network, is more than would be expected by chance alone in this distribution. And since the topology is fixed, it's net of the thing that you're describing. So whatever the propensity of attributes to contribute to the formation of a particular structure of the network, we take that as a given.
Okay, and another question. So when you describe dumb luck, I mean, some of it's dumb genetics. I mean, I presume I'm in my brother's social network.
Correct.
Or
That's right.
And
that's right.
BMI is systematically overstated for both of us because of we're big boned.
Right.
So,
me too, I'm with you, brother. I'm in the same group. Sign me up for that.
Right, so how does your sampling technique take into account the genetic link?
Okay, in a minute I'll show you things where we remove all the genetic ties. I'll show you some other images. But everything I've shown you so far, all the estimation keeps them in, but that might confound estimates at degree 1, but that's as far as it will reach.
Sure.
Because if you are Denise's sister, if I'm your brother and Denise is your sister, we take the shortest path length to me, so she doesn't count as distance 2, she only counts as distance 1. So we'd make one hop to you, my brother, but then the next hop would be to your brother's, to your wife, and then from your wife to her friend. So I'd be 3 degrees removed from your wife's friend. You see what I'm saying? Or your friend's spouse, or whatever it is. So at most, that's confounding just the 1 degree removed. And we've also done these tests removing the genetic ties. I'll show in a minute.
So when you compare those, you can sort of get a little bit of a peek at nature versus nurture, like relative to the amount of clustering you would see because people share the same genes, the social clustering that you get because they share the same non-genetic linkages is big or small?
I'd have to think more about that suggestion. We've done some other work. This came up in the talk earlier today, too. We've done some other work looking at the extent to which your weight status and the concordance of your weight status with the people to whom you're tied affects the kind of network that you are in. For instance, if you're bigger, do you have more friends than if you're smaller? Or if your weight is becoming more discordant from your friend's weight, are you more likely to sever the tie with that person regardless? But that's another topic, I think, of conversation. Okay, so when we see the cluster, and I'll actually come back to this at the end if there's a little bit more time then, because this topic's come up again and again today, and actually there's a whole set of questions that could be engaged. And once I present some of the results on smoking, we'll have more vocabulary, so we can talk a little bit about what happens to
It's a Dartmouth question.
Yeah, no, it's, yeah. Okay. So having observed the existence of homophily, observed the existence of clustering, now the question becomes, well, what's causing the clustering? And there are at least 3 possible explanations. One is homophily, the preferential tendency of like individuals to befriend like individuals, birds of a feather to flock together. So more educated people hang out with more educated people, Dartmouth people hang out with Dartmouth people, overweight people might hang